because they're paying for the food that you are eating. Yay. We have a couple announcements before we get started. I have one personally. Next week, Wednesday, 6:30, this exact spot, we're doing an intro to command line. So if you're interested in learning how to use your command line on your box or have people that are wanting to learn that you know, shoot them my way. And I think Andrew has an announcement as well. There's going to be a rockin' poster you're going to see soon, so for that one.
So I was asked, and also I guess internally motivated, to come up and invite everyone to apply for Maker Faire 2017. So it's makerfaircha.com, and applications are open until July 1st. And if you have a really awesome idea and you don't necessarily have the resources to do it, there are going to be grants available this year that you can apply for when you're applying to be a maker. Otherwise, it costs $0 to be a maker, to show and show off your passion at Maker Faire, and it's always a great time. It's going to be in September this year. It's really great to see everybody, and it's everything from people building drones and hydroponics farms and their own games, like software games, not other games, but other games also. But anyway, basically anything that like you do that you think is fun, it probably constitutes making. Anything with an artifact probably, but maybe not even with an artifact. Anyway, and we, the Chattanooga community, would love for you to come show it off to everyone else. So that's my Maker Faire pitch. Makerfaircha.com, check it out, and we'd love to see you there.
All right, so today we have Brian Bowden, and he will be talking about Kotlin with Android development. So let's welcome him up.
Hello, my name is Brian Bowden, and I'm a software engineer at Spire Labs, where I've been building Android apps for the past 4 years. I've lived in Chattanooga all my life, and it's been exciting to watch the tech scene in the city really take off. I'm excited to be a part of this today, and I want to thank all of you for coming out. So this afternoon, I'm here to introduce you to a programming language called Kotlin. We'll go over what it is, why you need it, and how it can help change the way you think about building Android apps. So what is Kotlin? At its core, Kotlin is an object-oriented, statically typed programming language that is designed to handle everyday tasks safely, elegantly, and efficiently. From a use case standpoint, it's very similar to Java, but don't let that scare you. Kotlin was designed to take down Java and replace it with something much better. Kotlin itself was designed by a company called JetBrains. This is the same company that built the popular IntelliJ IDE, and which later branched off into Android Studio. The team at JetBrains actually named the programming language after Kotlin Island, near their headquarters in St. Petersburg, Russia. The funny thing is that Java was also named after an island, so in a way, Kotlin's paying homage to its Java legacy. Kotlin was introduced in 2001 and made available as an open source project in 2012. Kotlin 1.0 was launched in February 2016, although by that time it had been used successfully in production for some time. And as of May 2017, not too long ago, Kotlin became the third officially supported language on Android, which is a pretty big deal for a third-party language. But Kotlin is definitely not just limited to Android. Kotlin builds to the standard JVM, as you might expect, but it can also build to the browser by means of compiling the JavaScript, although honestly, I'm not sure why you'd want to. And then Kotlin can also be built to run fully native as a binary, although right now that feature is still experimental. But since my own experience is in Android development, that's where I'll be focusing today. So first and foremost, one of the most significant aspects of Kotlin is that it works seamlessly with Java code and libraries. Java may not be everyone's favorite language, but there's no denying that the Java community has developed an enormously helpful ecosystem. Kotlin's interoperability with Java means that it can leverage the ecosystem rather than starting from scratch. On a more local level, Kotlin even just works seamlessly with your own Java classes too. That means you can gradually introduce Kotlin into existing projects without having to make a complete commitment. With just a little configuration, Kotlin can live side by side with your Java files in complete harmony. But why Kotlin? And what's so bad about Java, especially if it can continue to leverage its ecosystem? Well, there are several reasons, particularly in the case of Android development. For starters, Java has some ongoing issues that don't have obvious solutions. Java embraces nullability by default. That means that any object reference can potentially hold a null value, and there's no truly effective way to avoid peppering your code with null checks to avoid the dreaded null pointer exception. We could potentially use some third-party annotation libraries and code analyzers, but we're really just treating the symptom and not the disease. Secondly, Java can be incredibly verbose. A lot of verbosity is due to best practices commonly held in our industry, and in the name of writing safe code, a good bit of boilerplate is written just to produce a basic data class. Starting a new class often involves hunting for the right tool to auto-generate the structure you need, and that alone should be a sign that the language needs improvement. Thirdly, Java has a hard time unobtrusively extending platform types and other classes. Not a huge deal, but often end up creating lots of util files and other custom classes just to add basic functionality to something like a string. And while those are all valid issues, it gets even worse on Android. So Android is slow to adopt new Java features because it does not use the standard Java runtime that's managed by Oracle. So that means no Java updates. While the Java syntax on Android is identical to the Java you'd write for the JVM, it actually has its own implementation on Android. That means whenever new Java features are announced for new Java versions, the Android team has to start work re-implementing all those features on their own platform. And some features don't even make the cut. Finally, when new features are available, they're often only supported on the latest OS versions. So the solution for most production Android developers has been to use a collection of third-party backport plugins to support new language features. These backports allow us to write somewhat modern Java while having it compiled down to the target version we desire. This can get pretty messy, and you're relying on a lot of open source third-party plugins in an ever-changing ecosystem. Luckily, the devs at JetBrains recognized this struggle, and they were well positioned to offer up a solution. Their solution was Kotlin. Kotlin solves many of Java's shortcomings, particularly on Android. Kotlin not only limits boilerplate code, but also makes your code more resilient, less error-prone, and more declarative. So let's take some looks at Kotlin basics. This is going to be the crashiest of crash courses, and while I'm going to skim over some major concepts, I hope you'll be able to walk away with a general understanding of what makes Kotlin tick. And if you're familiar with Swift or C#, a lot of this should look somewhat familiar. So let's get into the Kotlin syntax. So here are some basic Kotlin variables. Notice that the type is declared after the variable, as opposed to before, like in Java and other languages. Also notice Kotlin has no semicolons. For variables, we have two primary initializers. For the keywords, we have val and var. Val creates an immutable read-only value, while var creates a mutable variable. Functions are pretty simple and defined using the fun keyword. Similar to variables, the return type is specified after the function header. And to write this more compactly, we can just write this function with an expression body. Rather than wrapping the function body in curly braces, we can simply set the function equal to the expression that calculates the return value. Here we're just using a conditional to determine a return value for this function. And in Kotlin, you can see that conditionals are nearly identical to just about any C-based language. However, in Kotlin, conditionals can also be treated as expressions. With this in mind, you can shorten the previous function to something like this. You may notice that this might behave like a ternary operator, and you'd be right, which is good because Kotlin doesn't actually support ternary operators. When it comes to data types, Kotlin's system should look pretty similar, but there are a few points worth highlighting. For instance, most of the Kotlin built-in types mirror those available in Java, like int, string, float, etc. However, there are no exposed primitive types in Kotlin. Instead, everything is an object. When interacting with Java code, primitive values from Java are automatically wrapped in objects usable by Kotlin. And these wrapped values behave pretty much like Java's own wrapper values for encapsulating primitives. Lastly, all Kotlin objects inherit from a base class called any, and that's similar to Java's object class as well. So one major issue addressed by Kotlin is nullability. As opposed to Java, Kotlin is designed to prevent null references at its very core. In Kotlin, all types are non-nullable by default. Attempting to assign a null value to a non-null variable will result in a compilation error. This convention creates more rigidity, but by having the compiler enforce this rule, null references can be all but eliminated when non-null values are guaranteed. For instance, if we continue the previous example, getting the length of A doesn't require a null check because A cannot ever be null. It doesn't matter what sort of operations you perform on variable A between its initialization and the call to A.length because it is guaranteed to have a non-null value at all times. But sometimes you need to be able to handle a null value, and in Kotlin, handling null types is simple and safe. Simply add a question mark at the end of the object type to mark that type as nullable. Once you declare a variable to be nullable, the compiler becomes very picky about what you can do. Attempt to access any properties or methods on this variable without a null check, and the compiler will immediately complain. Here we say that we're trying to get the length of string B, but the compiler throws an error. Since it was initialized as a nullable string, we can't simply reference its length unless we add some safety features. All right, now we've added a null check by means of a conditional expression. If B doesn't equal null, we can get the length. Otherwise, it'll just return -1. But this is pretty ugly and almost a little too much like Java. Luckily, there's a better way to handle this in Kotlin. And Kotlin has a feature called the save call operator, which is just a question mark and a dot. This operator automatically returns a non-null value if it exists. Otherwise, it returns null. In this example, we initialize a string B with a value and get its length. The length is returned as an integer value of 3 initially, but later we can set the B value to null, and we attempt to get the length of B and its length. But this also returns null. And that's due to the save call operator passing the null value back to L. This brings us to another one of Kotlin's null safety features. If you attempt to return a reference, or you attempt to reference a property or method on a value with a nullable type, then that property or method value is also considered to be nullable. This allows for a trickle down of null safety, and resulting values originating from a nullable type are also forced to be handled as potentially null at the compiler level. This trickle-down effect plays in our favor and allows us to do things like null-safe property chaining. If any one of these properties in the chain returns null, the entire expression returns null. In Java, doing something like this without a null check at each level is very dangerous, but in Kotlin, it's perfectly safe and acceptable. One cool little feature of Kotlin is its ability to infer nullability and type based on checks that have already taken place. In this example, we pass in a nullable string into the method. But once we're done with the null check in the if statement, the compiler knows there's no need to enforce the null safety any longer and treats the value as a non-nullable string. So this allows you to avoid constantly having to use the save call operator as long as you're performing operations on the string while inside the if branch. This also works with type checks. Here, the getStringLength method is passed a base object type of any, which is Kotlin's base object type, as we said. Any could be, well, anything, and that includes a string. So we do a type check to see if the object is a string, but once that's done, there's no need to do any sort of typecasting. Instead, the object is auto-cast to a string, and you can call the string's.length property without any extra effort. All right, moving on to classes. Classes in Kotlin are quite simple and take a lot of the grunt work and boilerplate out of the development process. Here we have a Kotlin class at its most basic. To add a primary constructor, we add it straight to the class header. We simply use the constructor keyword and define our parameters as we did earlier with functions. However, this is a bit clunky for normal use. Luckily, Kotlin provides us with a more concise format. If your primary constructor doesn't do anything special, like add annotations or set visibility modifiers, you can simply omit the constructor keyword and declare the class much like a function. If you need to do more than one constructor, you can create one or more secondary constructors. You can do this by creating a constructor method within the class, then following it with a colon and a reference to your primary constructor. Here we've added a constructor to a person class that takes a first and last name. However, the primary constructor requires a full name, so we use Kotlin's string template first and last names into a new string and provide that to the primary constructor. In Kotlin, you provide a body for your primary constructor using the init block. The init block will run after both primary and secondary constructors have been called, and it's a great place to perform any. It's completely optional. So if you're just building a basic data container class, you may not even need it. Once your class is defined, creating an object instance of a class is pretty straightforward. Here we just create a new person named Jim, and the variable infers its type from the person object. Note that unlike Java and similar languages, no new keyword is required to create a new instance of an object. So to store and access data within classes, Kotlin uses properties exclusively. Classes declare properties by using the val and var keywords like we've been using earlier, and this is different than Java. In Java, classes had fields, which are basically just basic class variables. Fields are not a thing in Kotlin. If you need to store data within a class, properties are the way to go. Properties look like normal variables at first, but they are backed by underlying getters and setters. So instead, when we interact with properties on a class, we just get or assign directly to the properties like so. Assigning to a property implicitly uses the built-in set method for the property, and reading the property uses the built-in get method. To simplify property declaration, we can add properties through the constructor itself by simply adding the val or var keywords to the constructor parameters. Additionally, we can provide default property values in line with the property initialization. This example allows us to have default empty values and specify what data we have upon object creation, if any. So because we have no default value set, or because we have a default value set, we don't have to specify any of the constructor properties upon initialization. Alternatively, we could just use the property name itself and assign just one of the properties, like first name. So in this instance, we set the first name to Jim, letting the other property initialize with their default empty values. Looking a bit deeper into properties, we can explicitly write out the get and set methods just to see what's going on. So in this example here, we're just mimicking the default property behavior. However, we could easily make alterations to the data here, or potentially add some validation or filtering. We can also define properties that don't have a backing value of their own, but instead provide access to values derived from other data in the class. In this example, we have a person class that takes a full name as a property in the constructor. Additionally, we have a first name property that is entirely reliant on the value of the full name. Because first name is a val and not a var, it has no set method because it can't be modified. And so we simply set a custom get method that extracts the first name out of the full name. Here we see that once we create an instance of the person with the full name of Rob Scott, we can simply access the first name property to get Rob's first name with minimal effort. Extending another class is fairly straightforward as well. One interesting thing to note is that by default, classes in Kotlin are final. You can't inherit from just any class. This was by design, and while I sometimes struggled to see the value myself, it does prevent tampering where it isn't welcome. If you want to extend a class, the parent class must include the open quantifier, as seen in the person class here. After that, typical behavior of class inheritance can take place. Recognizing that a lot of developers were building out many classes to simply hold basic data, JetBrains added a special class to Kotlin called the data class. A data class is designated by simply adding the data quantifier before the class declaration. The data class looks like a normal class, but it adds a few extra features by default. For instance, when you initialize a data class, Kotlin generates a few helper methods for you based off the properties that you fed into it. First, it adds a copy method that can clone or partially clone properties into a new object. Secondly, it creates an equals method for comparing instances at a property level. And finally, it also creates a helpful toString override that cleanly prints out the contents of the data object for logging or debugging. I personally use data classes all the time for handling parsed JSON responses and simple data encapsulation tasks. So now that we have all the fundamentals down, I'll shift focus to some of the more interesting developments in Kotlin. One of the major features in Kotlin is that it embraces higher order functions and Lambda expressions by default. And while this isn't a new concept for most of us, it's fairly new to the Java world, particularly on Android, where feature sets have been limited. At a basic level, a higher order function is a function that can take another function as an argument. In this example, we have a higher order function that takes a rep count and an action function as its own parameter. In Kotlin, we represent function parameters using the parentheses and arrow notation to indicate the required signature of a function that we can pass in. One of the requirements in this example, or our requirements in this example are pretty basic. We just need a function that takes an int and returns unit. And in Kotlin, a return type of unit basically just means it returns nothing. Somewhat similar to Java's return type of void. So our built-in repeat function might look like this, where we simply take the rep count, count down to 0, and use that repetition to call our action function every time as we run through the loop. So let's say for each repetition, we want to print out the remaining reps. We could build a function like the one here called print reps. Note that print reps function takes an int as a parameter and returns nothing, just like we specified for the action on the repeat function. So when we're ready to execute, we simply use the double colon and the print reps method name to create a method reference. We pass that method reference to the repeat function, set our rep count to 3, and then the result is that we print a countdown as print reps is executed 3 times by the repeat function. To make this even simpler, we can use Lambda Expressions to define a function in line with our repeat function. For those unfamiliar, a Lambda expression is basically an anonymous function that is created on demand and used anywhere in place of a method reference. And in Kotlin, a Lambda expression is fully enclosed by curly braces with the parameters on the left and the body of the expression on the right. We can further simplify this Lambda by removing the type on the parameter, since Kotlin is smart enough to infer the types. And if you want to get crazy, we don't have to actually include any name parameter or arrow indicator at all. And we can just do all this in one line. So if you have only one parameter in the Lambda expression, you have the option to just drop it entirely and use the built-in it variable to get the value passed into the Lambda. Sometimes this isn't great for readability, but if you're in the midst of a complex workflow and need to reduce clutter, this is a solid option to reduce functional boilerplate. So one other really cool feature introduced in Kotlin are extensions. Extensions are a convenient way to add additional methods and properties to existing classes without needing to extend the class itself or create awkward design patterns. This is an example of an extension function that adds a pluralize method to a built-in string type. To create an extension, you simply append the class that you want to extend to the function declaration, as we've done with string.pluralize, and write the rest of the function as if it were an actual member function of the class that you're extending. That means you have access to the string instance itself by using the built-in variable this, although in this particular code, we really only use this in the context of that string template. So here we have our string.pluralize extension function in use, and as you can see, it also works directly on string literals now. And if we declared our extension function at the project level, it will be available at any time we need to work on a string. And while extensions like this are most useful when made widely available, extensions can also be declared locally if you just happen to have an extension at a particular scope. So one important thing to note about extension functions is that they do not actually alter the class that they're extending. These functions actually are just normal functions that are compiled statically, and they exist separately from the classes that they're referencing. They're essentially conveniences provided by Kotlin that allow developers to avoid doing things like creating a string util class, and that you might use for otherwise just adding some basic features to built-in type. That means you can't do things like replace actual member methods or reference private class methods or properties inside that extension. All right, so what about Android? Personally, I believe Kotlin is one of the best things to happen to Android development in a long time. JetBrains went out of their way not only to bring Kotlin to Android for all version levels, but also included several built-in features in their compiler and plugins to make certain tasks in Android a breeze. Unfortunately, I don't have to give a full intro into Android development, but I'll introduce some basic concepts as we move along. So in Android, we define each app screen layout in an XML file. The XML file contains a hierarchy of different containers and elements that define the layout on the screen. At their base level, we call these views and view groups. Each XML tag corresponds to a specific class in Android that handles how each element is rendered. In the XML sample we see here, we've just created a view group called a linear layout that contains a text view. Linear layouts just show a linear stack of whatever views they contain, and text views are just what they sound like, a basic table. Now, since I need a little more than this to show off some Kotlin features, I'm going to add a bit more XML to our layout here. That should do it. Beautiful. Cutting out all the extra attributes, we can see that all I've done here is just add another text view called body label and a button called action button. All that other fluff was just silly aesthetic stuff like text size, color, etc. And now we just have our XML layout written up, and we're going to see what it looks like once we're done. There we go. So there's some basic labels and a button. The theme built into the app automatically includes the header and the app name at the top. So that's something we get for free. Of course, this XML isn't doing all the rendering itself, and we want to actually give that button something to do. So in Android, we have classes called activities that essentially act as a controller for the view of the entire screen. So let's take a look. To start off, I'm going to show you how we've been writing activities in Java, and this is just a really basic example. So we've created a class called mainActivity that extends the base activity class, and we've overridden the activities method called onCreate. onCreate runs after the activity has been initialized and signaled that it's ready to start building its views. Inside onCreate, we make a call to setContentView and pass in a reference to r.layout.activityMain, which is just a reference to the XML file that we were looking at earlier. This method will automatically take that XML and use it as an instruction set to generate the screen's view layout. But we have yet to add any functionality. To do that, we need to create some references to our button and labels. To find the view objects that represent our text views in our button, we use an activity method called findViewById. Using this method, we pass in the resource IDs based off those we assign to those views in the XML, and findViewById returns a generic view object that we have to cast back into the appropriate type. If this seems a bit clunky, that's because it is. It's the first song and dance that you learn as an Android developer, and it gets old fast. But we'll revisit that in a minute. So now that we have some view objects, let's add a click listener to that button. To save some space, I've removed some code here, but you can see that I've called setOnClickListener on the action button and passed in an onClickListener object to detect clicks on the action button itself. The onClick method inside the onClickListener is overridden with our onClick action, which in this example just changes the text in our two labels. So that's quite a bit of code for what really amounts to just 3 lines of actual business logic. So let's see what it looks like first. Hooray, the button works in our fake demo. So now let's see how things would be different in Kotlin. Creating the same activity in Kotlin requires you to use the same XML as before. However, the Kotlin plugin has a really helpful feature for eliminating some of the drudgery. This is the Kotlin equivalent of our initial activity without any view references or click listeners. As you can see, it's different syntax, but really not all that different from our initial Java activity. So let's go ahead and add some view references. Recall that in the Java class, this is what that looked like, specifically the last 3 lines. But Kotlin makes this easier. In Kotlin, manually creating view references isn't even necessary. Instead, the Kotlin plugin detects the XML layout we've requested and automatically creates all the references implicitly. That means we can go ahead and just write the code we care about. And we're done. Action button, title label, and body label are all available as if they are already class variables. And so we only need to expose them in our code when we actually need them. In addition, setting the action button's click listener can be done with a simple Lambda expression rather than specifying an entire onClick listener. As you can see, the parentheses around the Lambda can even be excluded because it's the only parameter, adding to even more elegance in the Kotlin code. So just for fun, let's put the full Java Kotlin and Kotlin classes side by side. As you can see, the amount of boilerplate code eliminated by Kotlin is pretty significant. This only becomes more significant as the app grows and more complex objects are introduced. For instance, let's do a side-by-side comparison of a typical user class in Java with a first and last name. As you can see, this isn't much of a contest. The fact is that in order to follow Java convention and future-proof your code, a minimum of 8 new lines of code must be added for every new field. In Kotlin, you may even be able to just throw it in on the same line with everything else, or at least until you need to override something and add some custom features. And really, this still isn't a fair competition because the Kotlin data class automatically creates all those custom utility methods we mentioned. You could theoretically ditch the convention around all the getters and setters in the Java class, use some public fields, and get something more pleasing to the eye, but we know from conventional wisdom that this is a terrible idea. So even then, it's still not as concise as Kotlin, and the Kotlin data class still has more features, built-in accessors, and null safety by default. Finally, there's one more thing I'd like to mention that while not part of the Kotlin standard feature set, you can potentially make the significant impact on the readability and flexibility of your Android app. Turns out that Kotlin's Lambda expressions and extension functions can be combined together to design a custom DSL for composing nested structures. So building upon this concept of custom builder-type DSLs in Kotlin, JetBrains created an Android library called Anko. The purpose of Anko is to replace XML with programmatically defined view layouts that exist alongside your Kotlin code. While Android's XML layout is actually quite smart and incorporates some hard-to-replicate features, Anko has managed to create a really complex or compelling syntax that adds a lot of flexibility. So for the sake of comparison, here's the basic XML layout we looked at earlier. And here's the programmatically defined Anko layout in Kotlin. Each of the root elements, like linear layout and text view, are actually extension functions now that are dynamically attached to the current context. And they take a single Lambda expression as the argument, like we did before with the set on click. And the context is passed onto the subsequent Lambdas, where you can declare even more layouts and create a deeper nested structure. And as this continues, it actually generates everything that the XML layout did, but just in sometimes more concise and more flexible form. So because this is just regular Kotlin code, we could actually just include this layout straight in our activities on create method. This technically eliminates the need for any separate layout file, and you can have your activity and its views all defined in one place. Personally, I would not recommend letting your view and controller be this tightly coupled, but in Kotlin you have a lot of options, so you can use whatever method that you see fit. And to wrap things up, I do want to take a short look at Kotlin's alternatives. To be completely fair, it's not the only language some of these features we covered, and others have more to offer in certain areas. For starters, Java 8 is finding its way to Android after 3 years, and it does contain higher order functions and lambdas, as well as other cool features like streams. And if you need to support older Android devices that don't have access to Java 8 features, there are backports available, like one called Retro Lambda, which adds Lambda support to your code, but rewrites it on a compile time to use basic Java 6 objects instead. Additionally, languages like Scala have been growing on Android as well, and Scala adds some more functional approaches to solving problems. The downside to using Scala on Android is that the build time is usually quite slow, and the standard library is pretty large. And on Android, where you have limited resources, library size is a big deal. And finally, there's React Native. React Native is great if you need to knock out a multi-platform app quickly using only JavaScript, but there are definite trade-offs, particularly in the Android world. Optimization is an ongoing issue, and solutions to tough problems still often involve diving into custom Java code at the end of the day. And in my personal opinion, while React Native is exciting, you forego a lot of control to gain speed to market. And when you try to add control back in, you may very well end up with a more complex and less performant app than you would if you had just started with a truly native language. All said, I still believe Kotlin is positioned as the best language choice for Android. Kotlin has a small standard library that is optimized for Android. It's concise, it's modern, and it's practical. You don't have to worry about backporting to support modern features, and as I've covered earlier in the talk, Kotlin adds core concepts like null safety and built-in conveniences that make it more compelling than ever. So that concludes all the material I had to share today, but I hope it was enough to give you a general idea of what Kotlin looks like and why it's worth learning. And if you've been considering getting into Android development but hated the idea of writing Java, maybe now is a great time to get started with Kotlin instead. So if you'd like to get more information, you can always visit Kotlin's official website at kotlinlang.org, and you can check out Kotlin on GitHub, or you can go chat with the community on the Kotlin Lang Slack. That's where you'll often find me. And finally, if you want to get your hands on some products written in Kotlin right here in Chattanooga, check out our latest Android apps at Spire Labs. And that's all I got. All right. So I think we have time for a couple questions once we have the mic.
Yeah, so with the snippets you showed, I wasn't sure how you how it can tell where the statements are separated. so I know, like in Java, there's semicolons. In Python, it's kind of like the way it's indented.
Right. So in Kotlin, there's no semicolons, and a lot of it is really just defined by the expression boundaries, and really just new lines. So it's pretty flexible. There's not a lot of like clear definition, but there's no sensitivities to white space or anything like that.
And I was also wondering, you said it worked really well in the Java ecosystem. I mean, can it directly include Java written library code?
It can, yeah. It works directly with that. And basically, Java and Kotlin both compiled down to bytecode. And at the compiler and IDE level, like as soon as you import a Java library, it shows up straight in the IntelliSense or wherever else you might need it, just as if you were running Java. So that's really one of the huge components as to like how I even got into it, because I was writing a lot of Java for our Android apps, and I didn't have time to like start from scratch. Any other questions?
Yeah, about halfway through the slides, I think you showed a getter only function on a virtual member variable kind of thing, but it was splitting on white space. Would it throw an exception if there was no white space, or how would that be handled, like exception handling in Kotlin and that?
That's a good question. Usually the convention is just have it on the next line with a space, but you can also use curly braces just to find a better like function body for those, if that's what you mean.
No, I mean if the full name did not contain a space, then when you tried to split on white space, it would not find any white space to split the string on.
Oh, so the actual implementation.
Yes.
Yeah, I mean, it's not a foolproof method, so it was just kind of,
But does Kotlin use exceptions like Java, or does it use other error handling?
Well, in that instance, it would just split it into a one-member array, and it would get the entire name.
Together.
Your talk was about Android development, but is there any, Kotlin for any other type of applications where you would normally use Java, or is it just mostly focused on Android?
I think Android was the area that really needed help the most, and that's really where Kotlin shines, but their intention was to fully support any other like JVM environments where you might have Java. I think it comes up to like stiffer competition because you get whatever's latest in Java, as well as like if you're running on a platform like a full-blown server, you could potentially use something like Scala and use any of those functional capabilities as well. But Kotlin's like really its biggest selling point is that it's a small, compact library that's really just pragmatic, and it's really good for like taking care of everyday tasks, which is what Java was kind of being used for, but like it's just kind of showing its age at this point. All right. Anybody else?
You mentioned that Kotlin can be really good for parsing JSON.
Well, it uses the basic JSON parsers that you could pull in from Java libraries, and like there are some good Android libraries or just generic libraries for parsing JSON. One's called Retrofit, and it's actually created by the company Square that does the card readers. They have a really well built out Android library ecosystem, and from that it just pipes it straight into an object, and that's what these data classes would be really good for. All right. Anybody else?
All right. Well, thanks everyone for coming out. Brian, thanks again for giving the talk.
Thank you.
Yeah, next week we have a talk on end-to-end quality with the Sonar ecosystem. Ann Campbell's giving that talk, so definitely come for that. We also have some swag at the back. Some of the other Chada people, myself included, dug through our sticker drawer and just like back there and other things. So anything back there is free, so please help yourself. And thanks for coming out. Give it up.
All right. Thank you.